in Mendham, the point is to fill in the equations with the speculation. That's the point. At least they're all things that can be numbers, and they're not all munged up. You could have all the ones about developing communication all as one big factor. You know, it's not like you say maybe the real equation has 19 factors. The real equation has infinite factors. It's connected to everything in the universe, but you can find the major factors enough to do calculations at it, be correct theoretically. Now, we're not to that point with this equation. This is not an equation where you get the numbers spit out to end. This is an equation that gives a framework so that we can isolate what we talk about to one thing at a time, right? So, for example, what you have been talking about, you know, these developments of how we actually even reproduce. Okay, well, that's just the fraction that develop life, right? Because either life is in abundance and it all dies off, in which case it wasn't life, it was an attempt at life, or else it gets the sustaining situation going one way or another. But then you talk about all these other barriers, and that's why there's three factors here. That's why the fraction of the living that develop intelligent life is there. And the next factor separates out the fraction of the intelligent life that will release, you know, electromagnetic waves that we could detect, or some other thing we could detect. And then the final one is still yet another factor that, even given that percentage, if you did know it or want to estimate it, how long do they do that? Okay, and these identify pretty well the factors that would be involved there. Yeah, they're hard to know, but you and I can still talk about them. You seem to think that's very unlikely. Okay, the first three factors we are going to be figuring out from the Kepler experiment, with the only caveat there is that by planets that could potentially support life, we mean life as we understand it, basically. Some analog or similar thing to Earth-like, because Kepler's looking for Earth-sized planets around sun-like stars. Assume that it was even just as a thought experiment that equations such as this allow for. Assume that the F factors for developing life, intelligent life, and technology are all 1. And L is, you know, billions of years. Then that means that with the first three factors, we can get an upper limit. Knowing the average rate of star formation, the fraction of those stars that have planets, and the average number of planets that can support life per star that has planets, when we know those three things, if they're all 1 in a million, then we're going to have 1 in a million cubed as the upper limit, the highest possible limit, assuming all the other factors are 100%. We know they're not, I don't think 100% of those that potentially that develop life, develop so-called intelligent life that would release waves into space. It may be that 100% develop life. I don't know. That would probably start to get semantic about this definition of that can potentially support life. But if something has what appear to be the elements, it's probably not going to be 100% on all of these other steps. If you assume it was 100%, then that would be the maximum, given the other three factors that we are going to have good estimates for in the next 5 years. The average rate of star formation per year in our galaxy, the fraction of those stars that have planets, and the average number of planets that could potentially support life, if by that we mean life as we understand it. We're going to know that for our own galaxy, right there. And whatever those factors multiply together becomes an upper ceiling for the most the entire equation can multiply together. And that's an interesting framework. And you could deny it. It's fun to go, oh, poo-poo things. But, I I mean, I don't put much stock in this. It's just compared to biodegradable man, and now your criticisms. It's ridiculous. Something you just love to say things like, "Oh, it's all unknown." The average rate of star formation per year in our galaxy, that has a number associated, and that's the other thing about these other ones that we can't know. The fraction of life that actually goes on to develop intelligence is what, as we would call it. Okay, we don't entirely know what intelligence is, but again, we have the model of, humans, maybe some other animals that might, given a few more million years, what's some threshold. That's going to be a real number, right? The fraction of, we might have to define what intelligence means, our signature for intelligence, let's say city structure, or, wireless communication. Whatever you might arbitrarily do when you're trying to measure this, once you find those life forms, there is some fraction of life that turns into having that kind of characteristic. So there is a number associated with this. And the fact that we might never be able to figure out that number is fine. That's one of the things the equation can tell us. But in fact, we will find out at least these first three. And we can estimate through bioevolutionary history, we can estimate what some of these things what percentages seem to be on Earth, right? Because we can find out eventually the initial conditions of life on Earth, and then we will reproduce that thousands of times in a lab. And we'll start to get a statistics of, how often, given the conditions of life, does the life actually form? And, the number will be off until we get those conditions just right, but we'll narrow in on that, given centuries possibly, maybe millennia it might take in some cases, but this one doesn't really seem that hard, Now, the fraction that go on to develop intelligent life, well, no, that we might not be able to really do anything, even generalizing from ourselves, because we just don't have enough history to generalize from ourselves. On the other hand, there's a lot of life forms on Earth, and we could use a study of the life forms on Earth. How many life forms were there, and when did they finally develop this train of what we consider intelligent life? There's a percentage in there, right? The total number of species and the number that can get to intelligent life in the amount of time we've been around. Also, we know that we're 6 million years away from chimps as cousins, common ancestors, so that means probably roughly chimps could evolve into an intelligent species in 6 million years, and we can use that to estimate those or get an idea of whether it's more like 90% or whether it's more like 0.00001%. So, yes. And that's all Great Tex is saying, at least what he claimed to me. I'm going to reply to my videos as saying, it's not that great like I'm saying, but it's better than just going, we can't even think about these issues. It's such a tiny percentage. Yeah, well, here's the way we broke it down into a lot of separate, potentially tiny percentages. The funny thing about tiny percentages and cosmology is that, 1 in a million chance means that there's millions of those chances have happened all around us. So there's just, millions and billions of things. So very low odds have a way of happening still, if they're true probabilities and possibilities. And this is the sun here. Right.